Hi class, this is Bill Berry with the second video in our Programming with Repetition series in our Intro to Programming with JavaScript class. We already in the first video looked a little bit at why we care about repetition, the kinds of scenarios that repetition might be useful for, and then we introduced the first looping control structure, the main type of loop that I want you to learn and get down. That's a while loop, and the while loop will run 0 or more times. Remember I said a while loop will do for anything, right? You can make a while loop do anything you want it to do. So if you don't like the fact that there's more presented or you get overwhelmed, you can always use a while loop. I'm going to try to show you that the for loop is not really so different. So I hope that you'll be able to see that that this is not that big of a deal. But we're going to look in this video at the second one, the second type of loop, and that is the for loop. So let's jump down there and let's get started with that. For loops are typically counter-based loops. Now they really can do more than that, but typically we think of them as loops that we can control with counters. So why do we need these things? Well, you might be saying, well, you know, my brain is already hurting. You're giving me too much data. Well, actually, I don't want you to think of this as being something totally different. It's a time saver. It's actually, if you think of it, kind of a special case of a while, because we do some things so typically with while loops, right? So think about it this way. We often need to control a loop by counting things. So for instance, we take this approach. You set a counter variable to 0, right? You start the loop, and then inside the loop somewhere you increment that. You tick it up by 1. And then that has counted how many times you're working through the loop. Right? And then you use the counter after the loop to display it, to do math on it, whatever you need to do, right? So you very often do this, and then this start the loop business, if you're using a while loop, is going to say something like, while I haven't yet done this 5 times, while I haven't yet completed this loop 10 times, right? Where you are using the counter variable to control the number of iterations. It turns out that is so common that they basically just made a special type of loop that does all of it. And rather than dispersing the code, it concentrates the code so that you can see it all in one convenient place. So really, it's just a special way to do loops where you know you can count, and it makes that easier, right? This is the for loop. That's why we have for loops, and that's you know, the basics. Now, I do want to show you it's really not so different. So I have this little animation to try to show that. So here's our while version of the thing I was just talking about. So variable count equals 1. Great, we start at 1. We keep looping while count is less than or equal to 5. And then within that, you do whatever else you need to do. There can be a lot of code here, but one of the things you have to do in the loop is you have to increment the count by 1. All right, the shortcut operator to do that's really easy. Count plus plus, right? It ticks it up by 1. So this is a loop that is going to be controlled by counting. This loop is going to run exactly 5 times. Count's going to be 1, then it's going to be 2, then it's going to be 3, then it's going to be 4, then it's going to be 5. And after it's done that 5 times, when count is incremented and it goes back and checks, count is now 6, the condition is now false, therefore it's going to come to the code after the close curly brace, and therefore in this case it's going to write out the count, right? So that's not earth-shattering code. It's very typical code. And again, we do this kind of thing so often where we want to control the loop by how many times it's going through. So I want to show you, before we even talk about the for syntax very specifically, let's watch what happens if I take the thing on the left, which is the while version, and I move it into the for version. Watch how similar the code is. The only difference is where I write that code. So here we go. Notice the count is represented there, right? In fact, the for has as its first thing establishing the count and setting it up so that you're ready to start running the loop. Second part. All right. Now we take the part that is the condition that's going to control how many times you execute, and it goes second. All right, so that's part of the for loop as well. And last, we actually move the count incrementing there too. So all we've done really to move from this version to this version is we've taken out the 3 pieces that are critical in controlling the loop, how many times it's going to execute, and we just moved them into one spot where they're all in one set of parentheses. If you think about it, that's all a for loop does. It just consolidates that code, takes those three things and puts them in one place to make life easy. So you can see the start, the stop, and the increment all in one spot. In terms of how code executes, it's going to execute exactly like the thing over here. Nothing different at all, right? The same order of code, it's going to do the same thing, right? So again, they're not so different, they're not so strange. All right, so let's take a quick look at an analogy, and then we're going to look at the code more specifically. All right, so in this case, the analogy for the for loop is you tell the robot, take 5 steps forward. All right, so we know the robot has to keep a count, and we also know that it has to have a starting point, right? So the robot can keep count and say, okay, I'm taking step 1, then step 2, then step 3, then step 4, then step 5. Now I've taken all 5 steps. I've counted up to 5. I was supposed to take 5. Good, I'm done. I can stop. So that's the kind of thing that you use a for loop for. Now, one thing to notice, though, we're going to see this in JavaScript as well as a lot of other modern languages. Sometimes we want to count from 0 and stop at 4. There's reasons for that. Remember, if you think back to the elements collection in the forms, if you use a form and you use the elements collection, the first item in the form is actually called 0, not 1, right? It's numbered 0. The index is 0. So it'd be the same thing of counting from 0 to 4 rather than 1 to 5. It's still 5 steps, right? So don't get confused if you see that in the future. All right. Now let's look very specifically at the what goes in each spot. First thing you do is inside the parentheses, you do the setup step. It's going to run this code one time before it does anything else, right? So before the loop even runs, it's going to start and set step count to 1. Second thing is you express the loop condition. Notice these are semicolons. These are not commas. It's an easy mistake to make. Okay. The next thing you put is the loop condition. So I'm going to run as long as what is true? Well, as long as I haven't yet reached 5. Start at 1, keep going while this variable hasn't reached 5. Notice, very typical. Boom, same variable here, boom, same variable here, boom. Then you put a semicolon and then you say, after each iteration, what do you need to do? And very often that is just incrementing the thing, right? So in this case, step count plus plus, just add 1 to the step count. Then inside, you can focus on just the stuff that you want to have happen, right, in each iteration, which is, in this case, taking a step. And just for fun, I'm writing out the step count so that you can see the whole thing. Now, you know at this point, after this curly brace closed, you know that the loop is finished. So all of the steps have been taken, and we can log something if we want, write out something, or move on with other logic, right? But we know that that's true, that all the steps have been taken once we hit this curly brace. So here's the output. Taking step 1, 2, 3, 4, 5. How many times did it run? Exactly 5 times. How do we know? We started at 1, we continued through 5. Another way to think of it, you could have said start at 0 and keep going while step count was less than 5, right? That would be another typical thing to see. Still would do the same thing, except it would say step 0, 1, 2, 3, and 4. Still would take 5 steps. All right, so that's a little bit more about the for loop code. All right, one other thing, well, I've mentioned it there, step count 0, going less than 5 is the condition would also work. All right. In terms of the algorithms, they're not documented a really different way, so you can follow this flowchart. If counter is greater than 5, then we go out. If it's less than or equal to 5, we continue going, take a step, increment the counter, keep going. So you can look at it that way, or you can write it in pseudocode. That works perfectly well. Right? You get the idea. But in this case, if we're going to write a for loop, we sort of describe the whole setup, right? Start at 1, continue through 5, increment by 1 each time, take a step forward. Right? So that's how our algorithms might look. Now, to practice with this stuff, here's a simple exercise to try, right? Count down from 100 to 0, stepping by 5s, right? So I want 195, 90, etc., all the way down to 0. Again, if you're in class with me, we'll do that one together. If not, it's a good practice for you. And so I will leave you to that. Pause here if you want to do that before you move on. Now, another good practice for your brain is to look on paper and see if you can figure out how many times each one of these loops is going to run. So stop and think about these things. So the first one, if we start at 13, and we continue while the number is less than or equal to 13, and we increment by 1 each time, how many times is this going to run? So think about that. Start at 13. Is 13 less than or equal to 13? Yes, so it's going to run one time. Then num increments, then it's 14. 14 is not less than or equal to 13. So how many times did this loop run? Exactly one time. How about this one? Start at 50. Continue while num is less than 50, incrementing num each time. So what does that do? Well, it starts at 50 and then it sets this to 50 and then it's going to say, hey, is num less than 50? Wait a minute, is 50 less than 50? No, that's false. So this is not going to need to run at all, right? So even though it looks like you've got a setup, the condition is going to keep that from running. And so the answer, it's not going to run any times, right? It's just like a while loop. It doesn't have to run any times at all. How about this one? Start at 82, end at 92. Great. All right, so for setting up the for loop, we're going to start with a variable called number and set it to start, which is 82. You're going to continue going while start is less than end, so while 82 is less than 92. And then each time through, we decrement num instead of incrementing it. So what is that going to do? That's going to start at 82, but then it's going to become 81 and then 80. Are we ever going to get to 92 counting downwards from 82? We're never going to get there, are we? So the answer to this one is, this is an infinite loop. This is not a good thing, right? We don't typically want to have loops that run forever. This is going to be a problem and you're going to have to kill your web page, right? You're going to have to close the web page or somehow get control of it to stop the script, right? So this is not good. So if you have a script that just sort of runs away and you'll see some little indication sometimes that it's still running or looping, then you have an infinite loop and you need to fix it. So you need to make, excuse me, you need to make progress toward reaching the goal, but you need to go in the right direction or you're never going to reach that. Okay, one more quick topic and then we will stop this video, and that is you can do nested loops. You can put loops inside of each other, just like you can put if statements inside loops or loops inside if statements. Like, you can do this any way you want, and a typical way to think about that is to do a multiplication table. I think that's the easiest example. In this case, we have a for loop here, and then inside it we have another for loop. This one's going to control the rows, and this one's going to control the columns. Notice it has to be that way because you have to print things out one at a time, column by column, right? You can't go down and then come back very easily. So this loop controls each row of printing, this controls each column of printing, and it's going to, it's a great exercise for you to actually walk through this and watch what happens with the variables. So let's do an example. Let's start with the first one. Row becomes 1, right? Great. Now column becomes 1. Then it writes out row times column. There's the 1 right there. Then column becomes 2. It does that multiplication. Column becomes 3, column becomes 4, column becomes 5, column becomes 6, 7, 8, 9, 10. Once column gets to 10, it's going to hit this, right? It's going to fall out of the loop and then it's going to document write a break. That's how we get from the end of this line to the beginning of this line. Then slower loop, the outer loop runs more slowly. Row becomes 2. Now we're working on this second row. Column becomes 1. 2, 3, 4, 5, 6, 7, 8, 9, 10. Row becomes 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Row becomes 4. So walk through that and watch what's happening at each step, and that'll give you a good idea of how a nested loop will work. It doesn't do anything different than a plain loop. It's just that you have multiple loops, so you're going to have an inner loop that runs faster and an outer loop that runs slower, and you could certainly have them nested more deeply. And if that's the case, the outer loop's going to run most slowly, the next one a little less slowly, and the inner one is going to be the fastest of them. So just an idea that you can nest things within each other with control structures, and it works just fine. All right. Now, one good question is, how would you make this pretty in HTML? Well, that's something we'll revisit later, but we're not going to handle it right now. Now, a couple of little mini challenges you can do if you want. These are things that should be well within your abilities right now. So I'll leave you with this as we wrap up this video, and so practice those if you'd like. If we're going to work in class together, then of course we will work on these and look at the solutions together in class. Otherwise, I appreciate you watching this video. In the next video, we're going to continue on with how you start combining all of the control structures that we understand, sequence, selection, and iteration, to write more interesting programs. We're going to look at some fun things that you can do with loops, some interesting little, little tools, little tricks. And so all of that's coming up in the next video. But for now, thanks for watching this one, and we'll see you in another one. Thanks.